Hi everyone, this is the tutorial for the Project 2 Numerical Analysis and Linear Algebra Applications for the class Engineering 1331, Spring Semester 2017. Group members Sitin Nguyen, Rodney and Sikit, and my name is Sitin. Alright, for the first one, the goal of this code is to create two functions updrive and the backsub to solve a linear equation system. The first one, I need to ask the user to input the matrix with any sign of matrix, and after that, I calculate the size of the matrix. And I create the up triangular. The input for the updrive function is the T1 is the matrix. This is the original matrix, and after that I use it to extract out all the rows on the row of the matrix, which is from the first column to the last column minus 1, like before the first column, the last column, sorry, except the last column. And B is I extract on the last column, and I also create the Z, the Z is a zero vector with the same row, the number of row of the original matrix with one column. And in here, my goal is I need to use the first value of the second row divided by the first values of the first row, and I use that number to multiply for the whole row in here, and less use the second row minus the first row time with that number. So in here, I use the masking to calculate the first value of the second number divided by the before the number, the reverse values. I put in here, and after that, from the column 1 to the second last column, I put on that number inside that. I use from the second number to the last one, I put it in to this one, I put in 8. And by using this method, I can eliminate the first value and make all of the first column. It just have 1 in the first row and the rest of them is 0. That's my goal. And this is, and after that I use the bit in here. I solving for the last column with the same method, which is I multiply the same z for the last column to have my new last column, and this should be the answer for the updrive function. And after that, I need to output like A and B, and after that I use F in F to bring to write the equation in the upper triangular form and display all the number of A and B. And after that I reannounce the function backsub. Basically, you can see this is the updrive. After they run to the updrive function, we can have the last value right here. This is x3 times 7 equal 5. So my goal is to make x3 equal 5 over 7. Yes, and after that I put it back to the second row. My second row is 2 x2 minus 2 x3 equal -1. I put it back to the second row, I can have this is my second row. I can have the value. I can calculate the value of x2. And after I have the value of x2 and x3, I plug it back to my first row right here. Should be 0 x2 plus 3 3x3 equal 4. I have x3, I have x2, and back substitute in here, I have the value of x1. That's it, my goal. In here, I use that method to calculate and back sub on and find on the x that I want, the solution x that I want, and I need to output to my mainstream right here. And before I do anything else, I need to this is my function. This will combine the up triangular. This way I need to use it. There are three conditions for this one. If the last if the last two of the last rows, last two value of the last row equals 0, it's on the row is equal 0, it means we have the infinity solution, and it's both of them have a different number, we have the unit solution, and it's on of this number on the left hand side equals 0 and the right hand side equals some number. It means like we have no solution for this one. And and I need to use the menu function to ask the user they wanna input another vector or not. And let me run this one. This is the vector, that's the matrix that I want. And yeah, you can see this is my upper triangular form, and this is my solution for this one. Thank you. Keep going to this project too. We have the second code that we have to do is the numerical analysis, which is we need the user will input any vector, it's a row vector, and we need to put inside the form of the polynomial function like this. Yeah, okay. First one, I ask the user input the matrix, and I calculate I still find the row and the number row up and the number column of the vector, and after that I check the size of the matrix vector I need. It's supposed to be one time, and after that I ask them to input the lower bound and the upper bound, and also the maximum error. By input this one, I want to make sure x1 supposed to be greater than x2, like bar 1 the lower part supposed to be like less than I want to make sure that the lower bound is less than the upper bound, so I check if the lower bound is greater than upper bound. I need to input again. And first one, I need to create the bisect root. And in the bisect root, the input for the bisect root is the row vector, the maximum error, lower bound, and upper bound. And for this one, first one, I let y1 is the function with the values as the x1, and y2 is the function result with the value at x2. And I calculate the highest power of the function that I want, the equation that I want. Equation that I want equal the length of the row vector minus 1 and the power I let it run from the high power to 0. And so in here I use like counter like from 1 to the length of v, and I just keep adding number. This is y1 equal y1 plus the values of v, the first value of v time x power of the first one. Basically right here you can see if the user input enter four elements, four numbers coefficient, and the highest power supposed to be 3. And I keep going like, and it like decreasing like 3, x2 and x, and this is the x0. And this is I calculate the function. I backs up like the lower bound to this one, and the with the x1 in here, and I have y1, and I backs up x2 in the function, I have y2, and this is what I calculate right here. And after that I use the while loop to check if the interval of these two number, if y1 times y2, if it's greater than 0, and I need to warning if there are no root in this bound, and the user needs to input the new two bounds for this one. And after I put input in here, I just keep going to calculate the y1 and y2 again. If there no if after 3 times and they don't have any root in here, it's supposed to be like function has the same size of both input, so it's either error and stop. Keep going. I calculate the maximum error. My maximum error equal the absolute values of the upper bound minus the lower bound, and I define like the root equals 0. This is my matrix. This is what I store. This is I store on the iteration number. In the number, and it is on the maximum error. Okay, and guessing is just like my guessing number is in like the midpoint. Guessing midpoint. I store all of them in this one. So I use the while loop. I calculate the midpoint. Midpoint equal like lower bound plus upper bound divided by 2. First one, I check if the maximum error greater than the maximum error of the input, user input right here, greater than or equal, so it keep run in the while loop. And I can find the first one. I need to find the midpoint, and if I have the midpoint right here, I calculate the values of the midpoint. I backs up to this function, the midpoint to this function to find y midpoint. So I use some condition right here. If I realize if my y1 equals 0, it means my root is equal x1, and if y2 equals 0, it means my root equal x2. And if ym equal, this is the function at x value, the midpoint x value equals 0, it means like my root equals xm. And else if I check the interval room 1 to m, like y1 times ym, if it's less than 0, it means I wanna change it, I wanna change value of x2 equal xm, and the rest of them I will make the x1 equal xm to check for the other interval. And I put on my guessing number, the number I put on the number, the guessing number, this the midpoint into the guess function matrix, and I count how many times of the nitre it end in nitre, and I put on the nitre number inside the root, the matrix. Also, I put on the number of the maximum error inside one matrix, and let's run for the first one. Let me run first. Lower bound equals 1, upper bound equals 1, and 0. So first, we have this one number right here. It's the iteration number. It's from 1 to 11. The iteration number is 11, and the root of the function is -1, and the maximum error is run from 1 to this number right here after 11 times. And after that, and also Dr. Fans want us to use this function to find the actual errors, and so I use the bisect root 2 in here. Bisect root 2 in here, I make the maximum error that I just calculate equal the new one right here, and I also make the root the root I just calculate equal the new root, and the natural number equal the natural number, and I calculate the length of the natural number I already extract out. It's a little vector store, the vector store on the iteration number. It's in equal 0, it's equal 11, and for all the actual error, I just I use the absolute value of the guessing number. The guessing number the guessing number is the midpoint that I guessing minus the root that I just calculate, and I output in here. I have and I calculate, and I have my actual error, and I want to output with the f, and in here more I need to plot. I want to plot. My plot is I plot I plot on the iteration number with the actual error in the marker in the diamond blue, and after that I plot on the iteration number with the maximum error which I calculate, and after that I use the exponential polyfish to draw the curve line through on the maximum error that I have, and in here just plot all of them in there, put the region, its name, actual error, data, exponential, low with the location it the best fit inside my wrap, and I label for the X label, Y label, and the title of my wrap. Also, I wanna put the function, the equation inside my wrap with the yield as f, s', and the tag. And after I read it, and as you can see, my output for this one supporting the root 2, maximum error 2, the natural number 2, and the actual error. In my main script right here, I need to input. Basically, I need to output exactly what I have. This is the first one with the bisect root 1. We just like copy exactly what we have in here to the main script right here. This is on my root. This is the maximum error and natural number, and this is second one. I want exactly that number in here, but like the actual error is the difference in the only difference between two of them is the actual error. So after that, I run this one again for you to see. This is 3, 14, and 6, 26, and 1 with the lower bound -1, the upper bound is 1, and the maximum error is 0. And you can see this is my graph, and you can see the actual error is supposed to be less than the maximum error a little bit, and it go on the way to here. This is my actual error, and this is the data, and this is all the numbers. As I calculate, this is my guessing number, and this is the actual number right here. And that's it for the project 2. Thank you for listening.